There are three states of matter: gas, liquid, and solid. Many pure substances can exist under appropriate condition of pressure and temperature as a gas, liquid, and solid. If you look at this diagram, the gas particles are far apart and it can move freely and fill the available space. But for liquid particles, the particles are close together but move around one another. And for solid particles, the particles are so close together in a regular array and do not move around one another. There are several differences in physical state. The first one is the volume of gas can be changed by changing the pressure or temperature. For example, if we have a piston filled with a gas, increase the pressure, the volume of the gas will be decreases. And then if we remove the pressure, the volume will expand again. But the volume of liquid and solid does not change significantly under pressure. Gases flow more freely than solid and liquid, so this behavior makes gases can be easily transported. The density of gases are relatively low compared to solid and liquid. The difference in the physical states are due to the particles in gas are much farther apart from each other compared to liquid and solid. Gas particles move freely in a container and colliding frequently with the walls of container. The force of this collision with the walls of the container called the pressure of the gas. There are two methods that can be used to measure the gas pressure. The first one is we have the barometer. Barometer is used to measure the atmospheric pressure. And the second one is we have the manometer. So manometer are devices used to measure the pressure of a gas in an experiment. Pressure results from a force exerted on an area. So the SI unit for force is in Newton. So the area is in meter squared. So the SI unit of pressure is Pascal, where 1 Pascal is equal to 1 Newton per meter squared. A much larger unit is the standard atmosphere. The average atmospheric pressure measured at sea level and 0 degrees Celsius. It is defined in terms of the Pascal. So 1 atm is equivalent to 101,325 Pascal, equivalent to 101,325 Newton per meter squared, equivalent to 760 millimeter mercury, equivalent to 760 torque. The physical behavior of a sample of gas can be described completely by four variables, which is the pressure, volume, temperature, and amount. These four variables are interdependent, which means that this one of the variables can be determined by measuring the other three variables. Now, let's think for a moment. The bubbles at the surface of the sea are much bigger than the bubbles at the bottom. A balloon at higher temperature is bigger than a balloon at lower temperature. Actually, there are three key relationships exist among the four gas variables. We have the Boyle's law, Charles' law, and also Avogadro's law. The Boyle's law shows the relationship between volume and pressure. At constant temperature, the volume occupied by a fixed amount of gas is inversely proportional to the applied pressure. That's why the pressure at the bottom of the sea is higher than the pressure at the surface. So, when the volume increases, pressure decreases. Right? At the lower pressure, volume of the gas are bigger than at the higher pressure. For Charles' law, at constant pressure and fixed amount of gas, the volume is directly proportional to the temperature. So at higher temperature, volume is bigger. At lower temperature, volume is smaller. For Avogadro's law, we are going to have a look at the relationship between volume and amount of gas. At constant temperature and pressure, volume is directly proportional to the amount of gas. For example, If you blow up a basketball, you are forcing more gas molecules into it. The more molecules that you add into this basketball, the higher the volume so that the basketball inflates. Combining the Boyle's law and Child's law, we can see that volume is directly proportional to the temperature and inversely proportional to the pressure. All of this relationship can be expressed as PV is equal to constant, where if you have two different volume, you will get a formula P1 V1 is equal to P2 V2. V over T is equal to constant, and then you will have a formula V1 over T1 is equal to V2 over T2. V over N is equal to constant, where V1 over N1 is equal to V2 over N2. And also PV over T is equal to constant, where P1 V1 over T1 is equal to P2 V2 over T2. At standard temperature and pressure, which is 1 atm and 0 degrees Celsius, 1 moles of any gases occupied by 22.4 liter, while at room temperature pressure, where the pressure is 1 atm, the temperature is 25 degrees Celsius, 1 moles of any gases is occupied by 24.0 liter. So that's it for today. Thank you for watching.